Okay, let's get started. Again, my name is Ashish Kulsresht. I'm the Manager of Technical Application Specialist Group at Qualitrol, which is a group of industry experts for various asset in the transmission and the generation electric power. And I'm joined today with my colleague Carlos DeLigi. And Carlos, will let you introduce in a second. Today's topic for the webinar is to talk about the partial discharge and the monitoring of partial discharge using a portable device. It should be about 25 minutes of presentation time between me and Carlos, and about 15-20 minutes of Q&A at the end of it. So hold on your questions to the end. You can submit them in writing using the Q&A box, or we can possibly unmute the line so you can ask them verbally as well. So let me introduce myself. I have about 20 years of experience in power management, mainly substation system integration and communication. And Carlos, I will let you introduce.
Hello, everyone. Welcome to our webinar. I appreciate for your time to be here today. My name is Carlos DeLigi. I'm part of the technical application team. I'm the GIS, gas insulated switchgear, and high voltage breaker specialist for Qualitrol. My background experience was with ABB, almost 12 years working for ABB and with those related equipments, and I recently joined Qualitrol to support on the monitoring solutions where it would involve those equipments. So again, thank you so much to be here today, and it's a pleasure for me to be here as well.
Thank you, Carlos.
Thank you.
So what's on the agenda today is mainly four topics. We'll start with a partial discharge and what really partial discharge is, with just a couple of slides. Then we'll get into how we can measure and monitor partial discharge using various techniques available to us. Carlos would be talking on the first two topics. Then I will come back in the presentation to talk about the difference between a portable device for the PD monitoring, partial discharge monitoring versus partial discharge measurement, or some devices which can do both. And then what are the features necessary for the portable partial discharge monitoring, commonly industry acceptance or the expectation on the portable PD device. We'll review that, including a quick overview of our own offering in that area. So with that, Carlos, I'm going to make you presenter.
Sure. Thank you, Ashish. Okay, as Ashish mentioned, I will take part of the first two topics, and in order to have a good understanding of the partial discharge and methods that can be applied to measure PD and about our portable, we must have an understanding first of the partial discharge. So partial discharge is a localized dielectric breakdown of a small portion of the electrical insulation. That means if it would be to the entire portion, it would not be the partial, it would be the breakdown, it would be the complete, it can be as no flashover. PD can occur at any point of the insulation system where the electrical field is disturbed by irregularities or high voltage stress. So if you have irregularities in your equipment or high voltage stress that insulation is not made to support that certain amount of voltage, it can have start with a PD and eventually lead to a breakdown or a flashover. So in the picture below here, we have plus and minus, which simulate the live conductor and the ground. And between, we have the insulation, which can be SF6, it can be oil, it can be air, also can be epoxy insulation. And we have a partial discharge showing between. So at some point of the insulation, if you have irregularities or if you have the increase of this partial discharge with the high voltage stress, this PD, this insulation will become a conductor. When it becomes a conductor, it allows to flow electrons through it. If it flows to plus to minus on the, as shown in the picture, then it would be the flashover. But we are trying to focus on the defect of this PD in order to, how can we approach to measure this partial discharge. So the electrical impulse caused by PD have a rise time on the order of less than 100 picoseconds. So let's remember, as a partial discharge, as considered an arc or a spark, will create electromagnetic waves. That electromagnetic waves can be captured by RF, radio frequency, and by that, captured by UHF. So UHF is a radio frequency between 300 and 3 gigahertz. So have an understanding of the partial discharge. We can focus on looking for the kind of discharge that we have on the GIS, on the transformer, and on the breaker. So starting off on the GIS, we have a bus bar here with the live conductor on the center, barrier insulator, and with 6 types of defects. First one will be the protrusion on the conductor. So that means on the live parts where you have the electricity flowing through the electrons, you have a failure here, or a defect, as mentioned here, and this can create an electric field that would decrease the space between ground to the face, and that can lead to a flashover or a breakdown. We also can have a protrusion on the enclosure, the same, but this would be considered more dangerous, as well as you have the electrons flowing through here. You have floating parts. Floating parts would be a part that will not either connect to the ground or connect to the live conductor, so it would be floating. By the electrical field, it can charge and eventually discharge as well. Next one would be a free particle. And in order to be a free particle, it has to be metallic in order to charge and discharge and cause that PD. We also can have voids by delamination between screens and insulation. What that means is you have the live conductor here, and between here you have the insulator, which is in the GIS or the epoxy insulator. Through the flow of electrons, the heat that can cause, it can expand and also can retract. That, if you have a gap between here, the epoxy and the conductor, it can cause voids by delamination. And when we talk about voids, we talk about bubbles. Whenever void or whenever PD is there, it's not going to get better. So if you have a void over there, a PD, you're going to roll the material and eventually as well lead to a failure. We have a voids in the insulation, which is voids, again, bubbles, and we have the epoxy insulator, and you can see here a bubble on the epoxy. That sometimes you can have passed through manufacture process, do a high voltage test, do a high voltage test after commission of the equipment, and it still didn't cut that bubble. That maybe not be a problem at the beginning, but eventually in the future it can increase and become a problem. Now, type of defects on the transformer. Transformer will have a coil, iron core insulation with paper, and also bushings. So you can have a discharge in coil winding. You also can have a corona discharge on the sharp edges as the protrusion on the live parts, on the ground parts, as mentioned on the GIS. Void discharge from the bushing. So on the bushing, you can have oil isolate bushing or resin bushing as well. So resin would be applied as the same as the epoxy, as in the GIS. You can have a bubble. Or in the oil, we have a bubble as well, where in the oil, which can create also PD. Floating parts, not proper connect to high voltage or ground. Again, the same as the GIS. And void discharge in the solid insulation material, which is in the bushing, can be resin. And surface discharge on the insulation material, or this is a good picture showing the insulation on the winding is isolated by paper. Types of defects on the high voltage breaker. So here we have an example of a dead tank breaker, the entrance and output entrance bushings. We have the interrupter over here, and we have the insulation part. Here will be the mechanism to operate that breaker. Protrusion on conductors. If you have a failure on the conductor, again, the same as in the GIS, it will decrease the size, the distance between ground to the conductor, and can lead for a partial discharge. To a failure, and the same intention for the ground side. Particles, again, it has to be metallic in order to cause PD. Bad contact between two conductors, and in the next slides we're going to be showing some pictures, and I have a good representation of a bad contact what it can cause. Voids in training and the insulation. This is not going to be epoxy, it can be fibra, but it can have the same issues with the void and erosion, and eventually lead to a breakdown. So those are the types for GIS, transformer, and breakers. But how can we detect this partial discharge not only in the GIS but in the transformer and in the breaker? So what are those methods that we can apply to capture those PDs? So first one is electromagnetic energy, which is coupling to the GIS chamber or transformer or breakers. It applies to the IC6270, which makes use of the coupling capacitor, but the IC6270 also refers to the radio frequency and the UHF. So the IC6270 with the coupling capacitor is more common use on the factories with those big equipments, and you can take to the side, but whenever you talk to GIS, bigger, larger substations, the capacitance of that substation would be too high, so it would not be making sense to have such equipment to the side to measure PD in there. But you can use the UHF, that's why I refer to the radio frequency and the UHF method. Acoustic pressure waves, due to the rapid expansion, where it applies to acoustic method, can also be applied, but not applied to all kind of measurements. It can detect PD, but for instance, it cannot detect PD on the void. The attenuation of the signal whenever you talk about acoustics is really too high. And by that, on void, since the bubble, for example, is internally on the box, the acoustics wave will be kept inside there and not be able to be captured with the acoustics. In case of the light emission, you can detect with the UV cameras. But again, in the box, if you have a spark, if you have every spark with PD can generate a light and it can detect with the UV cameras, but in the box you cannot see it. And how can you apply this to the GIS? But that's a possibility if you have a chance, and that somehow not on the epoxy insulator you can capture that with the light emissions. Case of the chemical breakdown products, in the case of the transformer, it applies for the DGA, which is the dissolved gas analysis. When you go to the transformer and take a sample to measure the hydrogen levels of the acetylene levels, is to measure if it has a PD or no inside. And in case of the GIS, you have the SO2. Since the SF6 is part of the GIS and the high voltage breakers, and is really good to distinguish the arc, all molecular systems not able to recombine as the SF6 again, it can become SF4. SF4 is a very reactive gas, so it will react with the closest component that is in there. It can be in the breaker, it can be moisture. So the easiest one would be to react with moisture. And by reacting with moisture, you can detect the chemical with SO2. It becomes the SO2. So all those methods are able to detect partial discharge, but the really effective ones that are used nowadays and is the electromagnetic with the UHF and acoustic pressure. So we will concentrate on the first two. So acoustic detection. So the method, accelerometers and ultrasonic microphones. So it will detect the acoustics waves. So it's sensitivity particularly for particles. But as I mentioned before, for voids on the insulator, the attenuation is too high and not be able to capture. Features of the acoustic signals can infer in the shape and movement of the particle. The acoustics can have a lot of interference since you are measuring from outside. So in order to have a clear picture of the PD, you want to eliminate all the noise. So it allows measurements to be taken externally to the GS. So acoustics, one of the benefits, you can, from outside, you can measure. So pinch point all parts of the GIS looking up for PD. Common use during site acceptance testing. So you also can use, as in the manufacturer commission, you also can use acoustics, but not with the benefit to capture all kind of failures. Accurate location by fingerprinting along the GIS or by time of flight using two sensors. So if you have two sensors in different positions and you can compare with the amplitude of that signal, you can localize the PD with the amplitude comparison. Again, as I mentioned before, the attenuation of the signal is high, so particularly on barriers, so unsuitable for detection of void-type defects. Often used to back up a UHF technique or where UHF cannot be applied. So UHF can apply for most of the equipment, or in case it doesn't have antenna, we can look it up to put antenna on that. But in case it cannot, there's no way we can do it. The only way would be to use the acoustics, but giving preference to the UHF since it's a better method. So not suitable to permanent monitoring as too many sensors would be required. So acoustics, if you want to have a good localization, do online monitor, you need a lot of sensors. So imagine have a big substation, it would be something really not cost effective to have. And electromagnetic detection, where it applies for the UHF, electrical field sensors near HV ports, so signal is easily detected if noise can be eliminated. So UHF, you have a noise background. You can have noise background as a radar detector, microwave, and other kinds of noise, but those have established some frequency. So you can eliminate. If you don't eliminate that, if you have PD in a lower frequency than that, you will be covering that PD, and you don't want that. You want to have a clean picture of your PD, eliminating all that background noise. So your partial discharge measurement must have the ability to eliminate all the noise. So UHF band for GIS and transformer offer very high sensitivity to all defect types and good noise rejection. As our portable, we can identify all the defects and also have the antenna outside to detect the unknown types of noise. So you have the common noise, we have established frequency, and we have the unknown noise coming from the outside that can also be eliminated. So you can have a clean picture of your partial discharge, so you can make a good analysis. So allow relatively PD, amplitude, and pulse activity to be measured. So with the amplitude, the frequency that partial discharge happen, it can compare and give you a description of your partial discharge. Signal contains information on the type of defect producing the PD, so defect classification is possible. So it's not only a matter to have an antenna internally or externally measuring the UHF signal from a PD, and not only as well a matter to storage that data. You need to have a smart system that can get that data and show to the user sometimes doesn't have a good experience with partial discharge. So it can do a classification of what kind of failure or PD it is, if it's a void, a floating, a corona. So automatically can identify and classify that PD. Time of flight measurement using two sensors allow accurate location of discharge. So you use the two antennas, or all the other antennas spread on the substation. You find that the localization of the PD by the amplitude and the frequency and comparison, and you can use an oscilloscope between those antennas that you know is somewhere there. So you can do the time of flight with the oscilloscope and compare the amplitude and do a calculation and precisely verify where is that PD occurring. High sensitivity of field sensors means that large sections of the GIS can be monitored effectively. It's proven that in a GIS, in a long bus bar, up to 10 meters, if you have a PD, it can be detected with the UHF. That's how sensitive is the UHF method. You have attenuation through turns or breakers or barriers, but it's still in a straight line, a bus bar, and 10 meters, you still can detect UHF signal, a partial discharge. So prefer method for high voltage test and online continuous monitoring. So for high voltage test, if you have to do a maintenance station and have to apply for a high voltage test later on, and you wanted to do a comparison to the classification, you want to synchronize with the frequency. So for instance, some customers use 60 hertz, other 50. But when a high voltage test, you're going to use a higher frequency. So our equipment gives you the possibility to compare with that, to connect to data set, and so you can do high voltage together with the PD monitoring. So it's not only for the online monitoring, but you also can do with the high voltage test together. In a CIGRE sensitivity investigation done in 1992 with a defect needle on a live conductor, it proved that the sensitivity of the UHF is higher than acoustics and the conventional 70. Again, on site you can put it on, but you need to spread the substation apart with the disconnector switch, since the capacitance of the GIS is really high. In the acoustics, you have a lot of attenuation, so UHF would fit better. Other defects with a needle fixed on the spacer, as I mentioned before, acoustic cannot detect it. The convention would be able to, but again, if it's where I mentioned before. So what makes a UHF PDM system so effective? So it detects all known types of PD and GIS and transformer. Easy interpretation of record data using the analysis of PD expert system. As I mentioned before, what to do with that data? You need to have a smart system, a smart software. Qualitrol with DMS, we have around 1 million of events of partial discharge. We got that events, we create a pattern to identify what is a corona, what is a particle, what is a void. So whenever you have these, when you're measuring, we compare with this data bank and show you this can be a void, this can be a particle. So it helps the user to interpret the data. So this is one of the differentiations that from Qualitrol and DMS. So effectively give a real-time warning of active PD. For example, you have a partial discharge that you don't consider that's dangerous for the moment, but you want to be advised whenever in the future it comes to increase that signal amplitude of that PD, you want it to be told if to take action. So you can set up time, alarm or warning event, so it can give you a real-time message to you. So provide clear identification of PD type and helps in determine the risk of the failure. So again, if it's increasing that signal, you must take action to prevent a breakdown. It's suitable for periodic and continuous online monitoring service with the use of our portable, or you can leave our portable running 24/7 and later on capture all the data and do comparisons. Or you can use as well the online monitoring with the Gen 3. That's our online monitoring, which you use the same system. The difference with the portable, you can monitor 6 channels with the noise gate antenna, and with the Gen 3 you can go up to 2,000 channels and more. So you can monitor your entire substations or other substation as well. So applicable across all system voltage as well. Is a IC approved technique for high voltage commission tests, so you can use together with the high voltage after you complete assembly your GIS and want to test. You can use as well with the high voltage test set. Extend application for other metal enclosed electrical plants, such as you can use circuit breakers, cable, and box and switch panels. Every partial discharge will create electromagnetic waves that can be captured by UHF. Here we have a good example of, imagine that this is a GIS with an enclosure, a metal enclosure. We have a box insulation over here, and we have a conductor where it will simulate partial discharge, a protrusion on the live conductor. So the PD, as I mentioned before, is fast. So it happens at 0.5 nanoseconds. We also have a UHF copper in that enclosure to be able to capture that signal. Whenever you apply the voltage, you see that the signal is trapped inside, but also can go through the barriers. That's why we also can put our sensors in some barriers, not in all of them, but the barriers that are not encapsulated with metal screen, we can capture that UHF signal, or with the UHF copper. So the waveform output will look like this, and we'll be looking for the amplitude and the frequency of occurrence of the partial discharge. What are the reasons for measuring PD? So if you have a partial discharge monitoring, it can use to early warning the system to show developing problems, so you can act and prevent failures. To save unnecessary inspection and maintenance as condition-based monitoring. So again, if you predict a problem and you prevent a failure, you are saving money, you're saving cost. And if you have a failure, even if you have your equipment under warranty, who is taking the cost on the waiting time of that parts of this field service person to do inspection, and then the materials later on and testing, they'll take a long time. It's not a simple thing to do. So condition-based monitoring, you want to do maintenance when it's really necessary to do maintenance. Some maintenance is necessary to do every 5, every 10, visual inspection, but internally, you don't want to keep opening things if it's not necessary. You only open if you actually have a PD. So in the case of the GIS, you want your GIS to be PD-free. So to prevent costly failures, a loss of supply through planning follow-up action. Again, if you have a problem, catastrophic in the case of the transformer will be even worse, but both can take a lead time to put your system back in service, and that can cost a lot of money, and we know that. So with the help of the PD, is a tool to prevent and give you a outsource to you to help to prevent those kind of failures. So, and also allow the operator to have the confidence and reliability when he needs to. I want to show you some good pictures of failures that cannot be prevented since they didn't have the use of partial discharge monitoring, and that was caused by a void. So imagine how was the work to remove this barrier from the GIS. Everything is compact, everything takes time. And you're not only dealing with that problem, you're dealing with the gas. Whenever you have a flashover, you have chemical, you have the SO2. You cannot touch the SO2, especially for us, humans really reactive to our skin, and of course it can cause cancer to us. It's proven that. So this is a good picture demonstrated that it can occur, and that's how bad it occurs. If the protection don't open after the failure, it can get even worse. In a partial discharge, the pressure will increase, and the rupture disk will blow up. And it will blow up with a hot gas coming out from that. With the hot gas coming out from that, if you have a person walking in the side of that, it can get serious injury. Next one was a PD cause with a particle, and eventually happened with the flashover. A particle will bounce, and we can detect that with partial discharge monitoring as well. If a particle of metal falls in the wrong place, it will lead to phase to ground or phase to phase failure. In this case, it was a failure phase to ground, and discharge over here from phase to ground. This was a case that could be prevented. That was 342 kV single line GIS. One of the plugs of the CT cables came off, and that's the floating parts. The electric field charged the material, giving possible to give discharge, and was able to detect with PD monitoring. By that, you prevent a catastrophic failure, fix and put it back in service, and you can do that in a matter of 1-2 days. The service actually can do in 1 day, but you need to call the engineer. So in an emergency basis, you can have a 1-day work and 2 days travel. So you act fast and you prevent it to happen a catastrophic failure. In the case of transformer fault, overheating, so actually this is a nice picture because it can get worse, and we know that. And catastrophic failure in the transformer can get even worse than that. So that was an overheating failure on the transformer. This was a contact problem on the transformer and an intern fault. It's a bull shot over here. And a high voltage breaker, bad contact can cause PD, and eventually as well lead for flashover. Can be between phase and ground. This case was between phase to ground, and it had to be replaced at the pole. This is a 500 kV, and that's one of the cases I want to show you. This was detected. It was able to prevent for actual flashover phase to ground. So this is an independent pole 500 kV breaker, and whenever you have a PD, you're going to cause erosion of that contact. So before it used to be silver contact, copper in the back, and now you can see that's it looks really bad. So the contact resistance would increase, and you can capture that with the PD, and you can capture that with the partial discharge monitoring. So in case when you detect that, you only need to replace this part and actually this part on the interrupter, and then put your system back in service. So the damage and the cost will be a lot less. Okay, now we'll pass to Ashish, and he will continue, and we can talk later on if you guys have any questions. Thank you for now.
So when the PD needs to be monitored or measured, so obviously the asset needs to be energized, so it cannot be done before commissioning. So once you commission the equipment aside, whether it's a GIS or a transformer, then right at the commissioning time, you can have a partial discharge test using either the UHF method or the acoustic method. Generally speaking, medium voltage to high voltage equipment up to 220 kV, people choose to use an acoustic-based measurement. For the extra high voltage, usually OEM supplies the UHF sensors built in due to the customer specification, and then using those sensors, customers and the OEMs use the on-site test during commissioning using the UHF method. And while continuous operation, the customers can choose to have a continuous online monitoring. The preferred method there is UHF. As Carlos explained earlier, UHF is sensitive across all types of partial discharge event within the GIS or a transformer. So that's one reason. The other reason, as I explained earlier, is the number of sensors required for UHF method is substantially less due to the sensitivity and the range. So the cost of online monitoring is substantially less using the UHF method. And once, whether you choose to use the continuous online monitoring during operation or not, periodically, pretty much every utilities around the world have their maintenance procedure, and during those maintenance procedure, then you can do the offline or the online measurements again to see if there is any PD in the asset using the either UHF or the acoustic method based on the kind of sensors you have built in. What you see in this slide is two coupler location at the bus interconnect, and if you have a partial discharge event, the location of the star, using a monitoring system, you can calculate the location using the time of flight from the two couplers, coupler 1 and coupler 2, and you can hopefully accurately characterize what kind of partial discharge event that is and prevent catastrophic damage in your system. So for the portable PD measurement, as the word portable suggests, it's a small unit, very intact, which you can carry around to multiple sites. That's what really the portable measurement unit we're talking about here. And it's suitable for high voltage tests during commissioning or in service for time-based PD measurement. And again, the portable PD unit could be either a UHF or an acoustic method based. And for Qualitrol, we supply primarily the UHF. We don't have the acoustic. We promote heavily into the UHF, as UHF can cover all kind of PD events in your system. So you can do the time-based PD measurement as a sample on the whole equipment, or you can do one part of the equipment at a time and measure the whole equipment. For the specific UHF portable PD measurement, the measurement, as the term suggests, is just to do the sample measurement as a discrete activity over a short period of time, usually a couple of minutes. You do sequentially all the sensors on the asset with a GIS or a transformer, versus the monitoring piece where you actually leave the portable equipment connected to the sensors and continue monitoring for an extended period of time. That could be from a couple of hours to a couple of days to a couple of months, and that's the solution Qualitrol promotes, that our portable unit can be left a year or months, whatever the application demand. Whenever you identify that I could have a PD problem, rather than having a continuous online monitoring, you can then have the portable unit run on the asset for the desired amount of time. Some of the PD events, like the floating particles, may not be active all the time, so having a continuous monitoring is one of the most effective methods to capture those events. So if you look at what's the necessary feature for the portable PD unit, especially if you leave it for continuous monitoring for extended period of time, it needs to have some remote access management capability rather than you standing in front of the asset with the unit in your hand. You can leave the unit connected to the asset and then have the unit send an alarm through a SCADA or send you a report and diagnostics remotely, so you don't have to go to the site every day. It should be able to, in addition to just the threshold measurement, should also do the characterization and the localization, which you can do with the multiple asset and a smart software running in the PD monitoring unit. It has to be weather resistant. It, of course, needs to have the noise gating, because in the UHF method, that's a very important piece. We need to factor out the external noise from the equipment signal inside. So it needs to have that feature to get a clear view of the partial discharge event inside the asset. It should also have the continuous PRPD, phase-resolved partial discharge recording capability for the accurate analysis of the monitored data. And then it should be able to generate specific reports based on the different substations and the asset within those substations, because you could be using the same unit to use across multiple sites. So versus the online monitoring, typically continuous online monitoring is customized to individual site. Here you would be carrying it across to multiple sites. So you need to have the capability for all kind of reporting based on the site and the location. It needs to be easy to configure, and it would be good, if you can have all the software and the interface part of the unit rather than carrying your own laptop with a variety of software interface to communicate with the portable unit. So this is a pretty self-contained unit, which is exactly what Qualitrol promotes for the UHF portable PD monitoring. So typical schematic, we support up to 6 UHF sensors, so you can have 6 sensors anywhere in your asset, and your noise antenna is a separate input coming in. Based on the fundamental frequency, you can have an external sync signal, 50 or 60 hertz. Then today is the communication time, so it has the USB and the Ethernet port to have a network connectivity, to have you remote access connection to SCADA using 6150 or any other industry standard protocol. This is just a quick snapshot from the actual portable unit. As you see on the top, you have got multiple channels, 6 channels you can look into. And what you see on the left top corner is the live 3D pattern on a 50 hertz system. On the right top left, you see the PRPD display with the peaks of the PD event in your system. And then on the bottom side, you see the current status of the amplitude with the historical archive and the event archive on the bottom right-hand side. So the screen interface is a touch screen, so you don't need to really carry the keyboard and the mouse with you. It's a pretty self-contained unit. So the real advantage with our solution is the software. So of course we have the UHF method, which is kind of the umbrella method to capture any kind of PD event in your system. We already established that earlier in the presentation. Coupled with that, if you have a great software, which is what we have, the Smart Sub software, which is the exact same software we use in our high-end continuous online monitoring for PD events and GIS. Gen 3 system is the exact same software we use in the portable PD, which, as Carlos explained earlier, has built on the over 15 years of millions of GIS PD event and the intelligence come across from those events. So we apply that in an artificial neural network to do a very high and highly accurate fault identification, the characterization and the location of the PD event in your system, and very good noise elimination. So you pretty much get no bias of the noise from outside. And then the big plus, the same unit you can use for the GIS or a transformer. So, 6 sensor on a transformer is more than what you need. On GIS, 6 may not be enough, but you can, any particular area of concern you have on the GIS, you can leave the unit up and running for a continuous monitoring if need to be. So, in summary, the software which is evolved in our case for our 15 years of development based on hundreds of installation, millions of partial discharge event, coupled with a state-of-the-art UHF portable PD measurement is what you need for an application to figure out the exact partial discharge problems in your transformer and GIS. The unit, couple of pictures from the marketing perspective. This is how the unit looks like. It is a rugged, weatherproof, self-contained case. Only thing you need is the power supply and the connection to your sensors and the synchronization signal. And it has its own carry case. You can roll the unit in with you wherever you go. So with that, it's the end of the presentation. We are now open for questions.
Where would your sort of locations be on the transformer? Basically just the bushing?
Yeah. No, it won't be in the bushing. It would be in the if it's an existing transformer, it would be on the hedge cover that you must be doing a retrofit in order to do localization. But you also can put in the drain valve, you can put an antenna without having to remove the oil and at least capture the partial discharge over there. We enforce that for the new products, the new transformer should already come with the antennas The sales guys and we are working with the end user to understand the system. So whenever they need to have a new transformer, they can request and put in their specifications to the add of the antennas, and we can work together with them as well.
Okay.
So the question from Carlos Gardella is, I'm interested on PD detection on high voltage power transformer, mainly bushing and CTPT measurements transformers, CTPT, which is the measurement piece of the transformer. And it says, I can't listen to this presentation, so a link would be useful. So as a Qualitrol offering, we don't really have a ready-made offering on the transformer bushing monitoring, but that's something which is in our development. So stay tuned for that. Sometime in the near future, we should have our own offering. And then on the measurement instrument transformers, basically, again the same thing. Thomas, you can correct me if I'm incorrect. I don't think we have a good offering on the instrument transformer. So our main offering right now is for the GIS and the transformer, and we have the online continuous monitoring option, and we have the portable PD monitoring option, both using the UHF method. The next question, Carlos, you have was how UHF couplers are installed on power transformer, and we had a similar question earlier, and the answer to that is if it's an existing transformer, then the options are limited, but you can put on the drain wall. We have a drain wall sensor without draining the oil from the transformer. It could be on a hatch. But if you are ordering a new transformer, we highly recommend that you specify built-in sensors. You may choose later on to have a continuous monitoring or not, but it's relatively inexpensive to order a new transformer with a built-in sensor, and there are multiple options available for all kind of price range, which are relatively inexpensive. And then you can use those sensors to use either a portable unit or a continuous online monitoring as per your desire in future.
It's Brandon here again. I'd like to ask a question about the time of flight capabilities of the portable PDM UHF device. So is that functionality within this device?
No. The time of flight, you would have to bring out oscilloscope to actually get the measurement, exactly the position where is the failure. For experience in most of the customers I've been, the localization it's enough to determine where is that PD occurring, and so you can detect where in that GIS must be open or not. But with the sensors installed, you can add the oscilloscope and do the time of flight. So that will be something apart. With our antennas, you can perform.
Okay. And do you guys have a rough cost for the portable unit yet?
I
don't think anybody. Yeah, I don't think we are all technical people on the call. So this is Brandon, right?
With the salesperson. Yeah.
Yeah, so we can have somebody follow up with you to give you some pricing on this. Frankly speaking, I have no idea. I have some ballpark numbers on the continuous online monitoring. I don't know enough about the pricing on the portable unit. Okay. We have another question submitted online from Amir. How does the portable Qualitrol PD monitor compare to the Doble? So again, this is not really a discussion for a competitive comparison, but generally speaking, I can state the strength of our solution versus rest of the competition, which we think is pretty universal, which is everything self-contained. You don't need any computer outside. Everything is self-contained. You don't need to worry about any software or firmware twist and tweak. And then it supports 6 UHF sensors, and I think our range is pretty wide. We cover 300 to 1500 megahertz. Many competition cover the subset of that, so our range is very versatile. Which is another comment there is the best signal to noise ratio is about 1 gigahertz or 1000 megahertz. So you need to be plus minus 200-300 megahertz of that range. So our range is an advantage to us. And then the biggest advantage is we have the most experience in the industry. As a DMS, have been selling this from the early 90s. It's almost 20 years. And the fact is that we have the most continuous online monitoring UHF PD installed in the world. That's a fact. And that has allowed us to build an experience of thousands and thousands of real event using the artificial neural network interpreted as over 1 million event database. So those are the key advantages we have versus the rest of the competition. So is there an equipment from Qualitrol that can test in an offline mode? Okay, that's from Jay Dulgan. And Thomas and Carlos, you want to take that?
I cannot see that question. I'm sorry.
The question is, do we have an equipment which can do the testing of or the PD measurement in an offline mode? So of course you need to connect some generator to the you need to have some simulation inside the transformer or the GIS instead of the full energized asset. So do we have an equipment which does the primary primary testing for the asset?
Okay, Thomas, correct me if I'm wrong, but it has to be energized or it has to go through the high voltage test set. You need to have voltage energy in order to detect the PD. You need to have electrical field to induce those particles in order to detect.
So I hope that answers the question, because the PD pattern really would be visible under the high voltage stress. So you need to have a high voltage test lab to simulate that. So it can't be just your normal portable unit you can use to apply some currents and voltages. Okay, the last question we have is the cost analysis from Ada Diop. I hope I pronounced your name correct. Has there been a cost analysis done on this to determine how much it would save in maintenance cost? And that's a great question, and that actually justifies the existence of Qualitrol. That our goal in life is to save money for the customer, and we do it by achieving continuous online monitoring, in this case continuous online PD monitoring. And there are lots of examples. I don't know how many we have captured in terms of formal paper or white note, but we'd be happy to discuss it one-to-one and share our findings with you, what we can do to justify the value of an online continuous monitoring, which you can achieve with a portable unit, especially for a transformer. One portable unit can do a continuous online monitoring for a transformer. For a GIS, it may not be enough. In that case, we do offer the continuous online monitoring for the GIS, which could be accommodating hundreds and hundreds of sensors if it need to be. And there is a proven business case on the cost benefit for that. Okay, Carlos and I appreciate everybody's time and participation. It's also a pleasure for us to share these findings with you. And please follow up with any questions you have at the end of this call. We'd be happy to answer them. And Brian would be sharing the presentation and the video once he's finished polishing up a little bit. Okay, thanks. Have a nice day.